Hey, Year 11, another couple of special cases here, some special functions. Right, two more that we're going to look at today, exponentials and hyperbolae. Right, you may have used that word in English maybe, but we're going to use it in a different way here. Anyway, exponential forms is where we have some number raised to the power of x. So you sort of think about this. Think of some number, something bigger than 1, let's say 2. If I have 2 to the 1, 2 to the 1 is 2. 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and so on. It starts getting really big really fast. If I go the other way, right, now hopefully you can remember that if I have something like a half, so that puts me in here, something like a half. If I raise something to the power of 1/2, it's the square root of that thing. So the square root of 2, I don't know, 1 point something. Now if this is a 0, something to 2 to the power of 0 is equal to 1. And if that's a negative number, it's like 1 over. So it's like 1 over 2, 1 over 4, 1 over 8, 1 over 16. So they become very small, quite quickly. They never get down to 0. Right? 1 over a really big number is close to 0, but it's not 0. Now we call this thing where it keeps getting closer and closer and closer, but never quite reaches that point. Right, so I go down here, it's super, super close. We call that an asymptote. Right, there's this word here, asymptote. Right, so it continues getting closer to this line here as x approaches negative infinity. Right, the value of this function, right, the value of this function, y equals say 2 to the x, approaches 0 but doesn't get there. It's an asymptote. Now, as it gets bigger, as x gets bigger, y gets really big. That is called an exponential function. There are, some special cases here. You'll study those more next year. The next one that we want to look at is a hyperbola. Now, without the e there, it's singular. With the e, hyperbole, plural. Right, one hyperbola, many hyperbole. Now, this function is discontinuous. It has a gap. Right, you can't draw the whole lot without taking your pen off the page. It looks like this. Now, the equation looks like this. Y equals 1 over x, or even xy equals 1 if you want. Now, the thing is that there are some interesting restrictions on the domain and range here, or back here. Domain, all real x. Range, y is strictly greater than 0. Can't be 0, got to be greater. Now over here, for my rectangular hyperbola, if y equals 1 over x, I can't divide by 0. Maybe some people can, not me. No, you can't divide by 0. That can't be a 0. So the function, there is a restriction on the domain there. X does not equal 0. Right? X does not equal 0. Can't be 0. Now, also, can I make y equals 0? 1 divided by what equals 0? It's not 0. 1 divided by 0 is a problem, and it's more likely to be a really big number than a really small number. If x was, like 10 billion, 1 divided by 10 billion is pretty close to 0, but it's not 0. Again, I have these asymptotes. Now, x can be really close to 0, but it can't be 0. If x is really big, y will be really close to 0, but can't be 0. So this has an interesting domain and range. X doesn't equal 0, y doesn't equal 0. That's all. Right? So we have these things called asymptotes. They're often drawn as a broken line, which is a bit tricky when it's the same, when it's coincident with the axis. But nonetheless, those broken lines has a pair of asymptotes. Okay, and I get these two parts to the graph. Right? I get this sort of positive part, this negative part. Righto, rectangular hyperbola. See these things, recognize them. 2 asymptotes for a hyperbola and 1 for an exponential. Righto, wonderful. That's it for this part. For this video, I will either see you tomorrow or see you in the next video.